last week we talked about how we find slope of a line, and we used a slope formula that I said wasn't really a mathematical formula, but it's just a way of remembering how to find the slope. What was the formula we used last week for slope?
Rise over run.
Rise over run, right? So what we did is we took the picture of a line, and we found 2 points on the line, and then we counted from one point to the other. We counted how much we go up or down. We counted how much we go to the right or to the left if you wanted. And then we use that to write a fraction, rise over run, and then we simplify it to get our slope. All right, now what we're going to be doing now is we're going to be finding the slope of a line without the picture. We're just going to give you the coordinates of 2 points. Now, I don't know what the 2 points are, so this is what we would call a general formula. So this formula will work for any 2 points. So first thing I want you to do is write, you don't have to write the whole thing out, but I want you to write these 2 points, the names of these 2 points. So I want you to notice we have an x and a y here, and we have an x and a y here. But since we have 2 points, we have 2 x's, we have 2 y's, so we're going to call them x1 and x2, and y1 and y2. That way we know the difference between them. All right, so go ahead and write those 2 points down. And what was the formula we used last week? One more time, I know we just said it. Rise over run, right? So the formula we used last week was rise over run. So let's think about what that actually means. When we're talking about rise, we're talking about how much we go which way?
Up or down.
Up or down. All right, which part of the coordinates of a point tells us how much that point is up or down from the origin? Is it the x coordinate or the y coordinate that tells us how high or low to go?
Y.
It's the y coordinate, right? Remember, the y axis is the vertical axis, so the y coordinate tells us to go up or down. So when we talk about the rise, we're talking about how much the y changes, how much it goes from one y value to another y value. And to figure out how far you go along the y axis, what do you think we might do? Let me ask a question a different way. If I want to find the distance between 2 points, let's say we're driving on the highway. You guys have driven on the highway and seen those mile marker signs? Yeah? Let's say that you start at mile marker 20 and you drive to mile marker 50. How far did you go? So if you start at 20 and you drive to 50, how far did you go? 30 miles, right? How'd you get that? No, you didn't add them, right? Because 20 plus 50 would give us 70, and we didn't go 70 miles.
I subtracted them.
You subtracted them, right? So you took the 50 minus the 20. So you took where you ended minus where you started. Well, we're going to do the same thing here. If we want to find the rise, we're going to take the y value that you ended at, which is y2, and then subtract y1. And when we're doing the run is going which way? Left or right? Run is left or right? Remember, rise is up or down, right? So run is left or right, so we're talking about the x-axis now. We can figure out how much we will move along the x-axis by subtracting the x's. So the slope formula looks like this. Okay, this is the mathematical formula that we're going to use to find slope between 2 points that we know. All right, so it's going to be on top, where the rise was, is going to be y2 minus y1, because that tells us how much we go up or down. And then our run is going to be x2 minus x1, because that tells us how much we go left or right. All right, so let's see how we would use this formula to find the slope. And again, what we're going to do is we're going to give you 2 points, kind of like we did in the opener today. The first part of the opener, we gave you 2 points. But what you did in the opener is you took those 2 points and plotted them in the coordinate plane, and then you found the rise over run. What we're going to do, and these are actually the same 2 points we had in the opener today, we're going to do that without plotting the points. We're just going to use the formula. So the first thing I'm going to do is I'm going to label what these points are, what the x1, x2, y1, y2 are going to be. So remember, every point is going to have the x-coordinate first and the y-coordinate second, right? So for each one of these, the first one's going to be x and the second one is going to be y. So this is going to be an x, this is going to be a y, this is going to be an x, and this is going to be a y. So I want you to go ahead and write the 2 points down, but underneath the points, I want you to write an x underneath the x-coordinate and a y underneath the y-coordinate for both of them. Now, when we do that, we have a problem, because how many x's are there? 2. And if I just call this one x and if I just call this one x, is there any way to tell which one's which? No. So what we're going to do is we're going to call this x1 and this one x2. And then we're going to call this one, since they're both y's, we're going to call this y1, and we're going to call this y2. So go ahead and make sure you have that underneath your points so that we know which one's which. And then what we're going to do is we're going to take those numbers, those x's and y's, and plug them into the formula. So you have this formula up on your notes already, but I'm gonna just write it up in the corner so that we have it. So we have m equals, so slope equals y2 minus y1 over x2 minus x1. All right, so if I want to find the slope for these 2 points, I'm going to write m equals, because we're finding slope, so we're always going to write m equals. And then on top of my fraction, I'm going to have y2 minus y1. So what is y2 that goes in here? What's y2? 3. So I'm looking here, this is y2, so that's going to be 3. So I'm going to have 3 here, minus y1. What's y1? Negative 3. So I have y2 minus y1. Should I write it like that? Is that a good way to write it? What should I probably do here? Well, minus a negative does mean plus. We'll come back to that. But for now, let's just put parentheses around it to make sure that we know that there's 2 negatives there. So it's minus a negative. All right, we're just setting the formula up now. We'll come back and talk about the math in a second. On the bottom, we're going to have x2 minus x1. So what's x2? What's going to go first down at the bottom? 0. And then x1? Negative 2. So again, we're subtracting a negative. We're kind of starting with a tricky one here, aren't we? Now, Carl already told us when we subtract a negative, that's the same thing as adding, right? So what I like to do here is circle those 2 negatives and make it a plus. So what we really have on top is 3 plus 3, which is 6. So on top we get 6. And then on the bottom we have the same thing. We have 0 minus negative 2, so the minus negative becomes a plus. 0 plus 2 is 2. Now, does this answer look familiar?
Yes.
Yeah, that's the same answer we got, but to get that answer in the opener, we had to take these 2 points here, plot them in the coordinate plane, draw the line between them, and then figure out which point to start at, and then do rise over run from there. And then we still need to do what we did in the opener, which is what? We need to reduce that. We need to simplify. So if we reduce by 2 here, we get what? And is that the same thing we got in the opener?
Yes.
Yeah. So we get the same answer, but it's a lot less work because we don't actually have to plot the points. This one will be a little easier because it doesn't have the negatives. So we're going to use that slope formula, and what we want to do every time, at least for now, is write the x's and y's. So we're going to call those x and y, but since we have 2 of each, we need to call them x1 and y1, and x2 and y2. And we're going to plug them into that formula. M equals y2 minus y1 over x2 minus x1. So on top, we've got m equals, and then the top of this is going to be y2 minus y1. What's y2? 9. And what's y1? 7. All right, so I'm just looking at these here. y2 is the second y value. y1 is the first y value, so it's going to be 9 minus 7 on top. That gives us our rise. And then our run is going to be x2 minus x1. So x2 is 5 minus x1 is 1. And then we go ahead and subtract it. Subtract 9 minus 7 and you get 2. On the bottom, 5 minus 1 is 4. And just like the last one, we need to check to see if we can simplify. Is there anything that goes into 2 that also goes into 4? 2 does, right? So we'll reduce by 2. And when we do that, what do we get on top?
1.
And what do we get on the bottom?
2.
2. Okay, notice a couple of things here. First of all, I'm always starting with m equals. Why do I do that? To show what? Yeah, that we're finding the slope, right? So we always start with m equals to show that we're finding the slope. Then we set up the formula. So I do y2 minus y1 over x2 minus x1. So that's going to be the next step. And then after that, I'm going to put an equal sign and then show what I get when I subtract those numbers. And then if I need to, one more step, I'm going to simplify. So I'm going to put an equal sign and write my final answer that's simplified. So between each of these steps, what do I have? I have an equal sign, right? So I'm showing that as I go from one step to another, each of these steps is equal to each other. So we want to make sure we have those equal signs between steps. All right, go ahead and give this one a try on your own. Got a bunch of negatives here, so make sure you're keeping them straight. All right, so we're going to use the formula again, y2 minus y1 over x2 minus x1. And before I start plugging things into that formula, I'm going to just label which one's which, so it's really easy to just plug stuff in where it needs to go. So we're going to have x and y, and then these are going to be the first point, so x1, y1, and these are going to be the second point, so x2, y2. All right, so in the slope formula, we're going to have on top y2 minus y1. What's y2? Negative 3 minus y1, which is negative 5. So I'm going to put that negative 5 in parentheses so we don't have those two negatives next to each other. Make sure that you have both of these negatives in there. All right, a lot of people, when we start dealing with negatives, when we're subtracting a negative, forget to put the subtraction in there and just put negative 3 minus 5. All right, make sure that you have both of them in there. This negative right here is from the formula, and this negative right here was on the 5 to start with. All right, then on the bottom we have x2, which is negative 4, minus x1, which is negative 2. All right. Looks like on both the top and the bottom, kind of like in that first one, we've got we've got two negatives in a row. We're subtracting negatives. So right here, these two negatives are going to become a positive, and right here, these two negatives are going to become a positive. So on top, we have negative 3 plus 5. Yeah, that's going to be a positive 2. So since this is now a positive 5, we have more positives than negatives. So we're going to get a positive 2 on top. And then on the bottom, we have negative 4 plus 2. Yeah, so we have more negatives than positives on the bottom. So this is going to be a negative 2. And there's actually two things I need to do this time to simplify it. Remember, we not only have to reduce by a common factor, but we also have to make sure what? There's no negative in the denominator. So it's an easy fix, an easy thing to take care of. If we have a negative in the denominator, what do we do with it?
Add it.
We're not going to add it. We're just going to move it to the top, right? So we're not allowed to have a negative in the bottom, but a positive divided by a negative gives us a negative answer, just like a negative divided by a positive would. So the first thing we're going to do to simplify this is we're just going to put the negative up on top. All right, now let's look at the number part. We have 2 over 2 for the numbers. So I think this is a pretty easy one. What goes into 2 that also goes into 2?
1. 2.
2, right? We're going to reduce by 2. And when we reduce by 2, we get 1 over 1. All right, so our slope, we could write it as negative 1, but remember when we do slope, we want to do rise over run, so I'm going to leave it as negative 1 over 1, and that is your final answer. It would be wrong if you put the negative number in the bottom with the 1 down here. Okay, you're not allowed to have negative numbers in the denominator of a fraction. All right, next one. Go ahead and give this one a try on your own. All right, so I'm going to start again by labeling the coordinates here. Shouldn't start with a y, should I? So we've got x1, y1, and x2, y2. And again, I just do that so it's easy to see what goes into the formula where. And so we've got m equals, I'll start with y2. What is y2, Niall? 3 minus y1, which is what, Taylor? Negative 3. All right, so we've got y2 minus y1 on the bottom, or on the top, and then on the bottom x2, which is what, Travion? Negative 2, and then minus x1, which is what, Ronnie? I say x2, I meant x1 if I said x2. So x2 minus x1, so what's x1? Ronnie? X1 right here. What is it? So then we'll go ahead and subtract top and bottom. Again, we have minus a negative here and minus a negative here. So those are both going to become pluses. And on top we end up with 3 plus 3, which is 6. And then on the bottom we have negative 2 plus 2. So we have 2 negatives and 2 positives. What's going to happen with those? They're going to make 0, right? They cancel each other out and we get 0. So what we have is 6 divided by 0. What is 6 divided by 0?
0.
Nope.
6.
Nope.
1.
Nope.
That.
Can you divide something by 0? So remember division. Let's say this was 6 divided by 2. If we said this was 6 divided by 2, let's say we have $6 and we want to give it to 2 people, we would figure out how much we would give to each person so that it's even, right? So 6 divided by 2 is 3 because you can give 2 people $3 each, right? So if we try to give $6 to 0 people, can we do that? No, we don't have anybody to give the money to, so it doesn't make any sense. You can't do anything divided by 0. So since you can't divide by 0, what kind of line do you think this is going to be?
Undefined.
It's going to be an undefined slope, so it's going to be what kind of line?
Straight.
What kind of line had undefined slope? Where did the skier fall off the line? Which one was it? Was it the horizontal line or the vertical line?
Vertical.
The vertical line, right? So actually, when we plot these 2 points, they're going to be straight on top of each other, and we're going to get a vertical line. So what we need to make sure we do here, we cannot do 6 divided by 0, so that means that this slope is
6.
undefined. Okay, this is going to be a vertical line, and when we get anything divided by 0, when we're doing slope, that means that the the points are directly on top of each other, and it's going to be a vertical line, so we call the slope of a vertical line undefined. All right, moving on to example 5. Go ahead and try this one on your own. All right, so just like always, I'm going to go ahead and label the points. So we have x1, y1, x2, y2. And I'm going to do something here that a lot of people like to do just to make it easy to plug stuff into the formula. Since we have y2 minus y1 over x2 minus x1, what some people like to do is when they set it up, make the fraction, put parentheses where the y2 goes, put parentheses where the y1 goes, and then do the same thing on the bottom. This way, all we have to do is just fill in the parentheses with the values for each of these coordinates. So what's going to go in the first one here? Y2 is what? Negative 3, and then y1? Negative 3, okay, and then on the bottom, x2? 0, and then y2? Negative 2. All right, we've been doing this to you a lot today, right? We've got minus and negative on both the top and the bottom. So this minus and negative becomes a plus, this minus and negative becomes a plus, and we end up with negative 3 plus 3 on the top is what? 0. Those 3's cancel each other out because one's positive, one's negative. And then on the bottom we have 0 plus 2, which is 2. All right, now on the last one we had 6 on top and 0 on the bottom, and we couldn't do it. So we had an undefined slope, which means that it was a vertical line. Can we do 0 divided by 2?
Yeah.
Yes. So if we have $0 and want to give it to 2 people, we can do that. We're just giving both of those people $0, right? So if we're dividing 0 things among however many people, 0 divided by anything is 0. All right, so the slope here is going to be 0. You could do 0 over 1. With 0, we'll usually just write 0 because we know a line with 0 slope is what kind of line? It's not undefined. Undefined was the vertical line. 0 and undefined are very different things. So which one was the line that the skier didn't go anywhere?
0.
The horizontal line, right? So we know that this one here is going to be a horizontal line because it has a 0 slope. That's the one where the skier just sat still because there was no slope to the hill. All right, one more example. This is a good example of why we would want to use the formula, because if we wanted to do this one by plotting the points, we would need a pretty big coordinate plane, right? So we would need a coordinate plane that on the y-axis goes all the way up to 56, and on the x-axis goes all the way up to 23. And so we can do this using the formula without ever having to graph the points. All right, so the first part on top is going to be y2, which is what? What goes here? 56. And then minus y1, which is -4, and then on the bottom we have x2 is 23, and then x1 is 11. So let's do the math here real quickly. We have minus a negative here, which is going to be a plus. So 56 plus 4 is 60. And on the bottom, 23 minus 11 is 12. Can we reduce that? I know we can reduce it because they're both even, so I can at least divide by 2. I'll give you a shortcut here. We can divide by 12. So if we reduce by 12, what are we going to get on top? 60 divided by 12. Anybody know what that is? 5. And then on the bottom, 12 divided by 12? 1. So the slope of this line is 5/1.